As we continue our journey with conic sections, we now want to turn our discussion to the ellipse. Now, a lot of you may know what an ellipse is, or you may even kind of call it an oval. And yes and no. The best way to describe an ellipse is a circle that has been elongated. It's like basically stretching that out. And so I'm just going to quickly draw something that is kind of elliptical. And with an ellipse, you've got a couple of key main things to talk about here. You have your center, of course. You also have these 2 points on either side. So we talked about with parabolas, you have a focus. With an ellipse, you have 2 foci. So we'll call them F1 and F2. All right. So like I said, with a parabola, you have just one focus. With an ellipse, you have 2 foci. And for any point that we have here on the ellipse, the sum of the distances from that point P to those 2 foci will be the same as the sum of the distances from any other point to these 2 foci. So in other words, the distance from P1 to F1 plus the distance from P1 to F2 will equal the distance from P2 to F1 plus the distance from P2 to F2. So there's a very interesting way that you can actually create an ellipse on your own. If you take 2 push pins and you tie a rope around each of them, or connecting them, and if you take a pencil and you go till the string is taut and you go around on both sides, you will be creating an ellipse. Because as long as the string is not stretchy, the length is going to stay the same. So wherever you are drawing your point, where you're drawing this, it's going to make these string pieces right here. So the combined distance is always going to be the same, whatever the length of the string is. And so you can actually draw your own your own ellipse. All right. So with the ellipse, we have what's called the major axis. Now the major axis is the line that goes through the 2 foci and actually will go through the center as well. And then we have this guy right here, which is going to be the minor axis. Now, typically what we do, we don't draw it all the way through that. It's really just going to be from end to end, from where it intersects with the ellipse. But the minor axis is going to be perpendicular to the major axis, and it's going to go through the center. Also, the points where, again, this is a very rough drawing, the points where the major axis intersects the ellipse are called your vertices. So vertex 1 and vertex 2. All right, so it's a basic idea about what's going on here. Now, if you look at the textbook, or a lot of textbooks, they try to give you like 4 different forms to worry about with the ellipse. There's really only one you got to worry about. And so let's talk about that right now. So the basic form for an ellipse will be x minus h quantity squared over a squared. Well, that is not neat. That's okay. No editing whatsoever. We're fine. Plus y minus k quantity squared over b squared is equal to 1. Now, a bit of a caveat here, something that we need to understand, is that here, a and b are not going to be the same. Because if a and b are the same, that means these denominators are the same, and you could multiply times that common denominator, and you would just end up with the equation for a circle. So remember, an ellipse is a circle that's stretched out either in the x direction or in the y direction. And we're going to be able to easily figure out which direction we're stretched in based on comparing A to B. So as we've seen over and over again, we saw this with the parabola, we've seen it with circles. If we want to talk about what the center is, the center is going to be the ordered pair HK. So it's very similar to the center you would have for a circle, For a parabola, we didn't call it the center, we called it the vertex, and it was actually a point on the parabola. The center is not a point for the ellipse. It's a reference point for us. Okay? All right, so that's the center, and then we need to talk about another variable that you don't even see in this form. Okay? And that is going to be the value of c. So c squared is going to equal, and I'm just going to do this. I'm going to say it's the absolute value. So in other words, it's the distance between a squared and b squared. So it's going to be the absolute value of that difference. Now, why am I saying it in absolute values? Well, because I don't want to have to worry about a second equation and saying, oh, well, if b is bigger or if a is bigger, just find the difference between those guys and look at it as absolute value. And that's going to inform you about c, because what happens with c is that it then tells you where your foci are. So when I'm looking at my picture, so here is my center, and we talked about how you have your two foci, right? The distance between your center and these foci will be the lowercase c, which is what we're going to find from that guy right there. So, yeah, easy thing to do. It doesn't take a lot of math to figure that one out. Something else to note here, and this is going to be true for every focus that we see with any conic section. It's always going to be within the little curved part. Like the curved part could like wrap around it. Okay, it's never going to be on the outside. Think about a parabola. Here's a parabola. Where was the focus? The focus was inside here, while the directrix, that line, was outside. Or I should look this. It was outside. It was underneath, right? And the same thing is going to be true when we talk about the hyperbola in the next section. All right, so let's do a quick example so you see how this form works. And again, it's not too crazy. You just have to pay attention, take your time. So if I were to take the equation x squared over 36 plus y squared over 25 is equal to 1. Okay, let's talk about where all this comes into play. So right away, we can see that in terms of our center, since our center should be HK, we don't see anything inside here, so we know that our center is just going to be the origin. I mean, really, like the first example they always give you in a section like this is an example where the center is the origin. We're not surprised. Now, from this guy right here, we can say that A is 6, and from here, B is 5. Now, here's an easy way to figure out what the shape is and the location is for our ellipse. The A and the B tell us how we are stretched out in the X and the Y direction, respectively. So whatever is underneath the X, in this case, the 6, now you may say, oh, I thought it was 36. Yes, but in the form, it's a square. So you take the square root of that, and it's 6. So that means in the X direction, we are going to be spaced out 6 units on either side of the center. In the Y direction, we're going to be spaced out 5 units on either side in the Y direction. And once we put those points in place, then the graph is a fairly simple exercise, and we can answer all kinds of great questions related to the ellipse. So if I were to do a very quick sketch here, my center is right here. Again, don't put a full-on point because it's just a reference point. You would go out 1, 2, 3, 4, 5, 6 units to the right, 6 units to the left, and then you would go up 2, 3, 4, up 5, and down 5 units. And then this is where you're going to put your points. So you went 6 units to the right, 6 units to the left, and that's because of this 6 right here. Then you'll go up 5, and you'll go down 5. Now, just cast your mind back to when we talked about circles a long, long time ago. When we talked about circles and we would find the radius, we would use that radius value and would go up, down, left, and right that number of units. So if the radius was 5, you'd go up, down, left, and right 5 units, and then you would draw the circle. But since this is not a circle and it's just an elongated one, it's the ellipse, the numbers are not exactly the same. But you do notice there is that symmetry. If I go 6 to the right, I go 6 to the left. I go 5 up, I go 5 down. And then from here, we should be able to draw a fairly reasonable ellipse. So it should look something like this. Again, it helps if you have practice drawing circles and you're just going to, stretch this out. Now, for my students, if I give you a graphing grid, you do want to be as accurate as possible. But really, if you can do something like this, I'd be thrilled, right? Now, let's think about all the questions that we have to answer here. So we want to find the center, done. We want to find the foci. Now, that's going to be a little more challenging because to find the foci, we need to find C. So let's think about what C is going to be. So switch back to the pen. C squared is supposed to be the difference of these two guys. So always take the larger one and then subtract off the smaller one, like this. And 36 minus 25 is equal to 11. Now this is C squared, mind you. So that means that the value for C is going to be the square root of 11. That means that from my center, my foci are going to be this many units away from it. Now, the foci are always going to be in the direction where the ellipse is stretched the most. So in this case, the number underneath the x is larger, so it means it's stretched in the x direction. And the square root of 11 is a little over 3. So we're just trying to come up with a general idea about where things are. It's going to be somewhere right about here for one of your foci, and then 1, 2, 3, something like this for your other focus. Now let's write these guys as an ordered pair. So as you can see, it's the x value that's changing. And one of these guys is going to be the square root of 11, 0, and the other one is negative the square root of 11, 0. Well, that is just a little bit off. Okay, so should make that a little bit better. Now, you can also write this and say plus or minus the square root of 11, 0. Since these guys can't be simplified to anything else, you just kind of leave it like that and you just move on. Let's talk about the vertices. So the vertices are going to be those ordered pairs that are in the stretched out direction. In this case, it's going to be in the x direction by 6 units. So it means one of these guys is going to be 6, 0, and the other guy is negative 6, 0. We also have this other part that we want to answer, which is going to be the length of the major axis. I'm just going to abbreviate it like that. The length of the major axis is going to be twice what that changes. So from the center to the vertex is 6 units. So double that is going to be 12, right? Because you're going 6 on the other side. 6 plus 6 is 12. And while we're here, let's talk about the length of the minor axis. And the length of the minor axis, since you're going up 5 and down 5 from here, that's a total change of 10. And then let's find the endpoints of the minor axis. Well, that's just going to be a change by 5 from the center. So it's going to be 0, positive 5, and then 0, negative 5. Okay? Let's see, what else do we need? So we have the center of the foci, vertices, length of the major axis, length and endpoints of the minor axis. Okay, let's do the domain. Now, I think for these, this is some of the easiest stuff we can do is finding the domain, right? For the stretch out to the left and to the right is 6 units. So you're going from an x value of negative 6 to positive 6. Brackets on both ends because we do have these points right here that we are including. So this is the point 6, 0. And then your range, as you go from bottom to top, the lowest the graph gets is negative 5, and the highest is positive 5. So even if we had the center in a completely different spot, we should still be able to come up with the domain and range just by paying attention to the values that are underneath the x and the y. So you take the square roots, and that tells you, like the square root of what's underneath the x, tells you how you move left and right from the center in the x direction. The square root of the value underneath the y stuff tells us how we are stretched from the center in the y direction. And so you draw a decent sketch, you put all the pieces together, and you can get all your answers. But they're not always going to be that easy, so let's try some other examples.